So next, let's do another composition example. Right, these can be a little bit more confusing. So let's do composition example number 2. So we'll do the same thing. We'll find f of g of x and g of f of x, but we'll do it with 2 different functions. So let's do f of x. Maybe f of x is a little bit more of like a polynomial this time. Not necessarily something we're trying to factor, but right, just sort of something on that line. And let's do g of x is maybe more linear. Maybe this is kind of a y equals mx plus b type form. So maybe this is 2x minus 1, something like that. So not trying to go crazy with our formulas here, just trying to have a couple different examples. So let's do Fogg and Goff. Let's do f of g of x and g of f of x. I guess we'll do them side by side again. That seemed fine. Throw just a little bit of a divider kind of down the middle. Let's keep these brother and sister problems. We'll keep them. We'll split up their room with this tape down the middle. Anyway, so f of g of x, Fogg, is, just like we said, f of g of x. So that's f, and then I'm going to put this g of x function as my input, right? So g of x is 2x minus 1. So 2x minus 1 goes into my parentheses. So what does f of x do as a function? So f of x squares the x plus 3 times the x and then adds 4. So our form here, right, is going to be quantity squared plus 3 times our quantity plus 4 on the end. So what's going in? Well, g of x is 2x minus 1. So 2x minus 1 into our parentheses. And then we get 2 things. This really, right, 2x minus 1 quantity squared. So this is them side by side. Plus, right, 3 times 2x is 6x. 3 times 1 minus 3 plus 4. So this is, right, we can either sort of FOIL this out or do our sort of box multiply. And so what we're going to get is 4x squared, right, minus 2x plus 1, right, plus this 6x. And then I guess we could do, right, a little bit of like term stuff as we go. Minus 3 and plus 4 would leave us with plus 1. So I'm kind of leaving that FOIL out for you guys as an exercise, but that's where we should end up. Last but not least, so what do we finish with? Our kind of final form here, right? So 4x squared is 4x squared. Minus 2x plus 6x. This is going to get us positive 2x, right? When all is said and done. Plus 1 and plus 1 is going to be plus 2. So what we get is just a new polynomial, right? It's not anything super wild. It's not really any kind of big jump necessarily from where we started, right? It's just a little bit of a new version. Goes up to x squareds. We're not really like doing a square into a square or something where we're going to get up to like a 4th power. That's not necessarily what's happening. And that's our final form. If we flip the roles around, right? G of f of x. G is on the outside, f is on the inside. So what happens here, right, is my sort of g function is a simpler function. This 2x minus 1 is sort of an mx plus b type form. And then f of x is longer, and that's going to be my input. So this is x squared plus 3x plus 4 going into 2 times the quantity minus 1. So the form is going to be, right, 2 times whatever's in our parentheses with a minus 1 on the end. Because we're not actually going to square our results here, we're going to get something that I guess is a little bit simpler. You can see this is just going to take less time overall to kind of work through. This is just a quick distribution, right? We'll just kind of multiply through. So 2x squared, right, plus 6x, 4 and 2 is plus 8. And then we'll subtract 1 off the end. And then just a quick kind of like terms. There's really not as many terms here, which means, of course, we don't have nearly as many things to sort of combine together. 2x squared plus 6x plus 8 minus 1 is going to be plus 7. So 2 obviously very different results coming here. These 2 forms are not necessarily related. I mean, depending on what we're working with, you could get very, very, very different answers for both of these. These end up sort of both as a quadratic kind of function, right? A squared term, an x term, and a constant, but obviously none of our like individual coefficients are really lining up in any kind of a pattern. So there's a second example. Squeeze all this stuff in there. That's everything. Very good. That's the end of 2.6.